Alright, we are back 40 minutes after the intended start time for this. Hopefully it actually starts this time. This has been postponed not 30 minutes, now it's 40 minutes. Okay, now hopefully the problems actually show up. There we go. I think they're showing up this time, right? Ah, there we go. Good. Good. I don't know how multiple of 9 is a division 1 problem, but it's probably going to be something a lot more complex than... Okay, this problem is loaded up first. We may as well just start here while the other two are loading up. So we got mult 9 at 2 minutes. End digit integer, some unknown digits marked with question mark. How many ways are there to fill each question mark with a digit so that it's positive and a multiple of 9? No leading zeros. Even though the number of ways can be very large, you should output the entire number. Okay, that's interesting. Sum will not exceed 10 to the 5th, so I mean it is 100,000 digits. Is this Python abuse? Can I just use Python abuse here? That's great, let's try Python abuse. Okay, so for something in Python abuse, it's pretty much when you have absurdly large numbers, like here. We can even do something like solve read-in. We got so our initial starting DP is always going to be, we can have remainders from 0 all the way to 8, so 9. So DP0 will be 1. And then we can do 1, 2, 3, 4, 5, 6, 7, 8, or 9 on the first digit. Everything else is something. Okay. So for I in range n, if I is so new DP setup is going to be O times 9. Okay, so first let's take the base case where we get a digit, so then that's just going to be the new DP array at a plus, okay, let's x equals int si equals dpx or dpa, because we take 0 and then if it's a 2 then we have to add 2 and then so on. So then we go to 2 and make sure this is being done modulo 9. Okay, that looks pretty good. Okay, now if it's equal to question mark, then we can do anything from 0 to 9, assuming that so if it's not 0, or if it's the first digit and it is 0, then that'll be false. And then this just tracks all of the possible ways. B plus this mod 9 equals B. So then we can shift by anything from base 0 to 9. After you have to say dp equals this, and then return anything with modulo 0. Okay, that's cool. Oh wait, we only did equals. We need to actually add the values. This one I don't think we technically need to add, but can still anyways, and it's basically same runtime. Okay. How do we get runtime error? I mean, it looks correct on the first 3 cases, and then the leftmost is not 0. The given integer is at least 1 question mark. The sum has to be at most 100,000. Okay, this is a bit weird because you should output the entire number. Maybe we need to return this as a string, because this is actually one of the first times I've seen like. Okay, let's do a quick test here. 64. That feels wrong. I don't know why, but that just seems complete. I mean, okay, actually no, that does make sense. Yeah, maybe it is some sort of okay, what? Okay, how are we getting double run? How are we still getting runtime errors? This is where is runtime error coming from? Okay, I think the input looks fine. Looks fine. There is no div by 0. Array modules are fine. Does it give can we get, oh shit. It just says runtime error. I mean, it is using a bunch of memory, so there is that. How about more info? Does it give 1 second, source limit 50,000 bytes? Yeah, there doesn't seem to be a really key thing that's giving me the answer there. And try a few really whack setups. I mean, there shouldn't be any real issue with this, right? Like, what even is the problem here? Okay, well, let me just try running on the base cases here. That seems to be working fine. Then, yeah, it's still runtime errors here. Yeah, it's just the same thing but slower now. I mean, there has to be like some sort of... I mean, how do you even... No, if the read in there works, then... Okay, there is literally nothing wrong here. Can I ask? Yeah, there should be some way I can ask a... I mean, Python should not have an integer limit, should it? It definitely should not have an integer limit here. It's either a question mark or a digit from 0 to 9. Leftmost is not 0. Give an integer. And it has to be the entire number. Yeah, watch as it doesn't allow large numbers. This feels like the sort of question that would trouble. I don't know what it is with this compiler, but wouldn't it be hilarious if this thing just says screw you to large numbers? Either that or I should just test the thing on my own. 2 to the exponent 25 is, okay, that's too big. 15, 16, okay, we can do 16, 65536. So 8, 16, 32, 64, 128, 1024, 'I think this should be enough, right? Yeah, we can just take a little bit of time to have this thing set up here. $49,000. So that's 49,000. Let's do another. Did about 1,000 each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think one more. 15. There we go. That should probably work. Yeah, of course it's going to have a bit of issues actually showing all of these on screen. But it will get there. Okay, we're looking at what else do we want? But let's see what the R problems are in the meantime. Prime number and palindrome. Consider the first n palindromic primes. How many of them have an even number of digits? How many of them have an odd number of digits? Palindromic prime number is a positive integer that's both prime and it's a palindrome. Leading zeros are not considered if terminating the number is a palindrome. Wait, is this really the first question? Yeah, that's the first question, isn't it? Oh wait, we need one more here. Then we get 65,536. Okay. Now if this has been calculated correctly, it should be returning 1 with a shit ton of zeros. Now if it returns an error, then that's probably saying a lot here. I cannot tell if the input is the input just lagging can't tell if the program is lagging because it's taking that long or something maybe, or it's just taking a very long time to actually print the output. Oh, there we go. Squeeze text 820 lines. Yeah, looks like it's working fine there. Yep, you can, 1 followed by a frick ton of zeros. And let's just restart shell, so then this probably cleans itself up. Is there a clean shell? Screw it, we can just X this out. X this out and then just start up a new shell. How many of them have an even number of digits? How many of them have an odd number of digits? By this logic, there's probably something that's of the first 8. Only 11 has 2 digits. We know that the digit sum has to be even, but does that help us at all? Okay, we can do a really gimmicky attempt here. One, two, three, four, five. Watch this be the answer, because I mean, it also helps that so many people have solved this, so there has to be some really silly cheese solution to this, right? Because I mean, like, yeah, there we go, see? Like, do I know that there's even digit primes past 11? I don't actually know if there is or not, but apparently there isn't. Okay, now we get fair distribution. Alice and Bob have returned in this question for the millionth time. There's 45 people that have solved this. She has already decided who is getting what toy. And where are we looking? And forgot the monetary values. And she ordered them in ascending value. They're always non-negative. It's fair no matter what the actual values were. It should not be them. Okay. You get the binary string S to represent the distribution. Yes, if it's fair and no otherwise, based on the monetary value. So is there like a way to make the monetary value of everything so that doesn't seem ridiculously unfair? Oh, we have to check for all V satisfying the constraints, apparently. So it's for all possible arrays satisfying v1, v2 to vn. As if you can make any array that is considered unfair, then it's... Yeah, so the first case always has to pass. Second case automatically passes. Yeah, third case. The fourth case fails since, like, you can just set the other two as high as possible and everything else doesn't really matter. Two, three, four, five. Okay, well, this is giving us some ideas already. So that immediately removes many possible situations. Then we have the issue of how do we distribute these? Because even something like this can fail if you have like 20 here. This is also 20. This is still 20, so it's a difference of 20, and then you can even have like anything that isn't 20 there. And now what exceed? It's exceed, not match, right? Yeah, it does not exceed, so it could be equal, and that's still considered fair. So pretty much our next rule is that we can only have, like, these two have to be different. We can never have 3. Can we ever have 3 in a row? If we do 0, then 1, then 1, 0, 1, 1, 0, 0. Something like this. This might also, yeah, this also fails for that reason. Where you set 1, 1, 1, 1, 1, 1, and then 0. You get a value above here. So the next idea is can you do absolute values distribution? So 0, 1, 1, 0, and now we're back to 0. We're back to 1. This is valid. I'm pretty sure this is valid. Yeah, this has to be valid. Now we go here, this is balanced, and then -1. So we can actually do this in another way, where we do if we ever get to 2, then it's not possible, otherwise it's yes. Not bad. And with those two early solves, that does place us back in the running for the moment. Okay, so multiples of 9. What even is going on with this mess of a problem? The R2 are negative stones. And continuous subways, and then there's a few more problems that are there. Okay. For each test case output the answer on the new line. That's already been done. I am convinced that like this problem is just I'm gonna put a question mark here because this question has officially deserved the dreaded question mark. What? Wait, why are we getting a... Did I input the correct value? Okay, yeah, I did. Didn't even input the correct value. Okay, that might be a problem. Yeah, now I'm just doing some dubious experimentation. This should be 1. Okay, now let's try 1 question 5-3 gives 12. 2 question 5-3. Shit. 1 5 2 5 3 11. This gives 10. Yeah, now I'm just... This is almost a brute force troll setup. 100. Okay. 1, 7, and I can only assume 1, 2, 3, 4, 5, 6. Something like this gives 100,000 as expected. So it's just a number of... I mean, there's another case that we need to be careful with, I'm pretty sure. Which is something like this, since 0 fails and 9 fails. We are so back. Okay, so what can we determine first? We pretty much have 4 cases, I think. If I'm looking at this correctly, we have 4 cases. So first digit is either a question mark or anything else. And then remainder, so mod 9 basically, 0, and then 1 to 8. That's our main cases, and we need to know how many question marks we have. So let's just go with this first, because I'm really sure that this problem is just here to troll. So if 0 equals add 1 and first becomes false. Now for a in range 1 to n, we've already checked that first digit. If SA is a question mark, Q plus 1, else R. I think this looks about right here. Yeah, everything here looks about right. Okay, so now if we can fill in first, or if first is already filled in, then we have here, else if R mod 9 equals 0 and else. Okay, so based on our test cases, what do we have? In this case, if it's filled and if the first one is filled and we have a non-mod 9, then return times Q. That's our string that we return. If it is equal to 0, do we have a case where it's equal to 0? 1 question 5 3. Then return 1 times Q minus 1 plus 2. Now if we don't have it filled, then return 1 plus q minus 1. Otherwise, I think we should have. Then it becomes kind of like the double question mark case, right? Oh shoot, how do we do double question mark case? Two, 1, 10. Do we have a scenario where we already did that? 1. No. Okay, we can just add in a few extra cases here. 1. Question 6 gives 1000. Now if we change this to a 0, still 1000. Okay, so let's just assume this entire setup is correct. Because I mean, what else is it going to be here? 1, 10, and 2. Okay, so we're about to find out if this really was the problem. Or at least it should be correct. Maybe. Yeah, of course. So, what we've learned is CodeChef does not like large numbers, even if you're trying Python abuse. Thank you, CodeChef. Very cool. Okay, so next problem, move stones. We're approaching this at 59 minutes. I can figure out when this problem occurs. So this one I read a little bit earlier. Pretty much you just take you have to take two adjacent values. You can add or subtract one value to one of them and then reverse and do the reverse on the other one. Choose an index I, any integer x. And then find how many operations are needed to make AI greater than or equal to 0. So remove all the negative values. Okay, so first obvious thing is if sum of array is negative, otherwise it is possible. So like every negative value will probably need one operation at minimum. So we can just go like here, neutralize with those two, so then that takes 2 moves. Just add 2, subtract 2, you get -1, add 1, -1. I mean, we could still have a case where it's like -4, or even no, -2, 1, 3, 1, 1, -4. I'm pretty sure here it takes 1, 2, 3, 4, 5 moves. I'm not sure if it's possible to do it in 4. Because you have to take... Because either that or you just... Here -1. Cancel it out to get 2. And then you have 2, 1, 1, -4. Yeah, that would still take 5 moves. Okay, continuous subarrays actually looks like it's having better chances here, so I may as well look at that as well. And then we'll decide which one I want to go on. Array B linked M is good only if the absolute difference between any two adjacent elements does not exceed the length of the array. How many subarrays are good? So how many pairs are there such that This is another classic case of there's an easy n squared operation, but on is a little bit harder. So a single length array is automatically good. We can take the pairs. Then it becomes like a sort of sparse table, but not actually a sparse table. Where we sort of have the maximums. Like we can even let's use 8 because 8 is going to be our primary case. 2, 2. Obviously, we're not going to be storing all of this exactly, so we need to find a better way of storing this. Current total is 8, but we have all of these possible outcomes. One 6 means that pretty much everything up to about 5 is auto-cancelled. So all of those are eliminated. Six and 9. It's pretty much anything within that. You can think of it like this here. So that should go down to about the 6, right? Because a 2, 9 will also be forced to include, will also force to include the remaining. Yeah, so that automatically eliminates 4, all of the 4s, 5, 6s. Does not eliminate the 7s though. Then 2 there, however, that does eliminate 2, 3, 4, 5, 6, 7. That does eliminate those 7s. 10 and 9, so that's completely fine. 5, 9 to 5 is So then you get the 2, you get the 4, and you get the 8, like this. I mean, another way to put this is like 2, 2. Four, 2, 6, 7. One, 3, 2. So 4, 2, then 2, 3, 4, 5. 6. Anything contained in this triangle is eliminated. Then this just goes one further. 1, there's nil. mean, that does tell you, like, the absolute worst case is every second one. Actually, is that even the worst case? Like, if you have the 2 6 here. Yeah, it's because it covers everything, but then since you're already at 4 to 6 here, that becomes 5 to 6. Yeah, the 4 doesn't get double covered. Either way, that still feels like an n squared operation setup. I mean, the other way is we use the alternate triangle system where we just shift all the rows so it makes like upper right triangle. That one I'm not entirely sure how it... Is there a way to condense this into like a single dimension information wise? Okay, maybe. Okay, let's try and think of this differently. How do we do this without using the triangular system? Wait, there's another thing we can do. Didn't we just we just wrote the difference array 4267132. Or actually no. The difference array is 5, 3, 7, 8, 1, 4, and then 3.
Good morning.
Yeah, good morning. Okay. We can order these into a queue so that we pop them out from their lowest value to the highest value. Then we and then after that we just see how many connections we get. Keep track of all the segments that are connecting. where we get the length of all the segments. And then at every amount we Now, can this work? That's the question. I think this actually can work. Because the way we set it up, we're actually going to have fewer than n segments. I don't know what the exact amount is, but if I recall correctly, 200,000. If it's even square root, it's possible. I mean, it is a 1 second time limit, but in Python, but the one good thing here is that CodeChef does give Python a little bit of mercy rule. Talking about this. Activate trap card. ABS. So we need the difference between these two. Then we want to include these from lowest to highest, so br.sort. We can even do a reverse here and treat this as like a sort of stack. So limit is 2, since we need our difference to be at most 2. Now, how do we go about this limiting? And we need to just track the segment links correctly. So what we're doing is we're so for a in range 2, or I'm gonna do limit, since we want to keep limit up to I think n, so n plus 1. So 1, 0 is limit. Then our x, the position we need to get is br minus 1, 1. Remove there. LR is segmenting to n minus 1, I think. If x is not 0, or if x is not n minus 2, or not, if it's not 0, then L equals the segment value of, that way we can check if it's an endpoint. If it's connecting to there. If L equals 0 and R equals 0, then 1 seg L, if L equals 0, then it's right side. L if R is 0, then it's a full extension. We do not need to consider any So yeah, we need to be really careful with how we use the set. Okay, so seg plus it's a one segment d dot get if it's one and limit is 2, then we're doing like 2 segments. Okay, we need to look at Python set. Set methods. Yeah, so set dot add here. So then we need to set seg x plus r, I think. So if it's a 1, then plus 1 will just be 1. If it's 2, then the right endpoint of this segment is going to be 2 units away. And then 3 units away, 4 units away. I think that's how it works, right? Seg r plus 1, it's plus 2. Yeah, plus equals 1. If it was not 1, then there's a hanging point. But even if there is a hanging point, does it matter? I don't think it actually matters, does it? Yeah, it won't actually matter. So then dr minus if this is now 0 and something with the limit, then s dot remove r. Now what is this limit? Well, if we have, well, on distance 3 we have to get rid of, when we're checking for 3 we cannot, like 1 units in here correspond to too long in the array. When checking for 4, if we have a segment 2, then that's equal to length 3. So if our limit is 4, then we need at least a 3 here. So if it's this, or if one is beneath the limit, then remove it. Now if and this is relevant. If it attempts to remove here, oh, okay, wait, maybe we want discard here. Discard might be more helpful, so then we don't get errors. Okay, now we need to do L minus L if this or it's subliminal. New length is going to be, okay, now what is the new length? I think it should be L plus R plus 1. In this case, we don't even have to mark here. We just do X minus L and X plus R. And then we just this is non-D, and now is 0, L plus equals 1, if D equals 1, and that's if it's underneath the limit. Otherwise, just get out. So now we need to go through limit and range. For u in S, if u plus 1 is underneath our limit, then it should not even be possible. U plus 1 less than limit. Then this is a case where we have something like a seg1 on a limit 3. Then s dot discard u. Otherwise, we have to count how many segments we have here. So that's du for number of segments times u plus 2, I think, minus limit. And that'll be the number of subarrays in that segment that will pass according to our requirements. Turn answer, and there's just one more thing, which is we need to set our starting answer value to 10. Okay, now let's see. Something's probably feels inaccurate here. Seg 132, line 32. If x is not equal to n minus 1, okay, this is actually n minus 2. Okay. List is list. List dot u or v in the list s dot discard v. Six, 3, 4, 11. Okay, that's seems a little inaccurate. So 2 and then increases. Does this at least remain consistent? 2, 4, 8. So we hit a 2, we hit a 4, and we hit an 8. Okay, so last case seems to be working correctly. Then what is going on the other scenarios? What could possibly be going on there? Okay, what commit changes are here? Yeah, you can discard those. Then what is going on here? We have cannot detect any of those. It's the threes that seem to be the threes seem to be having some problems here. If our limit is 2, okay, we can actually be a little bit generous here. Because even if we're off by a little bit, it's fine. Let's say our limit is 10. Then definitely segments of length 3 are going to fail. Yeah, segments of length 5 even. Yeah, so we can just change all of these to 5s. There's not really any problem with adding doesn't have any problems with duplicates, right? Surely there isn't. Let's make sure that we're not putting in negatives. Six, 4, 5, 11. That looks like it's working. Okay, screw it. Let's try this here. This feels like a n to the 1.5 idea. Like, I think this could work. Or at least there's let's go. That's a very good solve. That is a really, really strong solve. Given that there's 17 minutes left and that I actually have some other things to do, mainly that I tend to do these contests before work and work is starting pretty soon. I probably might want to just call it off here. Call this as the finish line for my contest run today. And I'd say this was actually quite a fine run. So yeah, and the chances of me getting negative stones in 16 minutes is not great, admittedly. So yeah, I think I'm probably gonna just finish off for today here. So that is going to be it. Very nice having a good contest for once. And yeah, I will see you all later.